One of the advantages of using a feedstock that produces what is now referred to as green diesel or renewable diesel or gasoline or jet fuel is that once it's produced, once it's manufactured, it uses the existing distribution system. You don't have to have new tankage. You don't have to have new type of pipelines. You don't have to change out steel pipelines for some other type, for example, like you would have to with piped hydrogen or biodiesel for that matter. It doesn't have the water affinity that ethanol has. There are just a whole number of reasons why using a feedstock that produces a conventional fuel is much more feasible. I mean, it should be obvious, but it doesn't hurt to rehearse them. There's no engine changes required, no institutional changes required. The tax and administrative structure is all in place. None of that requires any changing because you're producing a product that meets ASTM standards. I think it's ASTM 957, I believe, is the diesel fuel standard. At any rate, all of those systems, all of that machinery, all of that social acceptance is in place. And there is no public behavior change. In fact, if you were to change to this fuel, the public would probably not detect it at the pump at all, unless, of course, informed, except that the diesel fuel wouldn't be quite as pungent. That's the only detectable difference. Other than that, the flame spread, the cetane rating, all of that is the same. Critical to the success of using fog as a feedstock for a biomass refining or blending system is that it be fresh. The fog molecule is a triglyceride. It's comprised of 3 fatty acids, 16 to 22 carbon pairs on a glycerol bond, and it's very susceptible to cracking. I'll show you why here in a minute. But grease interceptors are not a good environment for the preservation of grease. It breaks down. The fatty acid, you've heard the term free fatty acids. Well, that's when the fatty acid breaks the glycerol bond and is free in the environment, aqueous environment. pH drops precipitously. The adding air, incidentally, is a very good idea. I remember when they used to call them primary aeration basins in wastewater treatment plants. But at any rate, the molecule has to be harvested quickly. We make all kinds of cleaning products and so on to break that molecule to make them easy to clean from surfaces. And those products are generally pretty effective. And so the shorter exposure and the quicker we remove the proximity of those products and the activity of the hydrogen and oxygen atoms in the water molecule, the more intact that triglyceride is and the more susceptible or more amenable it is to fuel production. Typically 2 to 3% free fatty acid is considered a significant compromise. Once again, with a GRD, which is a grease removal device, it's essentially an adaptation of a standard hydromechanical interceptor, already recognized in codes and standards. It transfers the fog from the interceptor rapidly into a container, removes it from most of the water, and that makes it more adaptable to use as a fuel. Once again, this requires no administrative or physical infrastructure change. You design your grease waste piping just as you always did. Sizing, just as you always did. This is an example of my favorite GRD, since I represent J.R. Smith Manufacturing. This unit, as you can see, has the solids interceptor, has the hydromechanical grease interceptor, and at the far end you'll see a tower that stands up on the end of the interceptor, which is the actual removal device. Removes it through a belt system with a small agitator at the bottom, which enables the grease to migrate to the belt. Takes it up, puts it in a container, see-through container that you can tell when it needs to be dumped into a receptacle. The advantage of this type, once again, adaptability, is that that top can be fit right on a standard hydromechanical grease interceptor. You don't even have to take out the old grease interceptor. Just take the lid off, set this unit on, plug it in, and you're in business. You're in the oil business. Where's John? I didn't mean to say anything about Texas. This is the product flow chart. You'll notice there that it talks about hydrolysis. Well, hydrolysis is one of the means by which that molecule can be cracked. And depolymerization is another. That's a high temperature in the presence of a fluid, sometimes water. There are several other methods, but essentially they're cracking plants. Some of you might be familiar with that when they were that term when they were using those as means of recycling used oil. This is a molecular structure of the fatty acid that is one of the prevalent. Palmitic acid, oleic, stearic are the common acids that you'll find in a FOG triglyceride. And at the bottom here is cetane. Now this is the flame potential, rate of flame, etc. Let's call it the energy potential for a layman's term of diesel fuel. I use diesel fuel a lot because I think composite diesel is probably going to be the resulting liquid automotive fuel. It can be made from a number of things. It has more energy per unit of measure. It now with clean burning, high efficiency diesel engines, you get a tremendous boost in power, and some of the newer ones, even with the low sulfur diesel, don't require particle separators, and without converters are meeting CAFE standards in terms of mileage and air pollution standards. Now look at the similarity between the carbon pairs on the palmitic acid and the cetane. You can see why that's so amenable to a fuel. It's nearly there. The most common method of converting fog to energy is methane gas, typically in an anaerobic digester, a Caldane's plant, if you're familiar with that term. It's a method of converting organic material with a 16 to 22 carbon pair chain structure, or less, but that's the most suitable, into methane at the wastewater treatment plant. Now, that works well, and it's been in existence for half a century or more. There's a common term, I'll let your imaginations figure out what that is, but the last part of it is gas. Anyway, that's been around for a long time, been used as heating. It's been used for on-site power generation. In fact, in the municipal plant in the town near where I come from, they've been using it to generate heat for 40-some years. It's moderately efficient in terms of the amount of energy that you have going in the molecule of the fog versus the amount of methane that you're getting out that you're ultimately converting into usable energy. It's considered a moderate yield. It has certain advantages in that it's there. The infrastructure is part of most modern wastewater treatment plants. They're harvested. It's harvested from landfills now. The Hibernia plant out here has a fantastic generator. They use jet engines to turn generators and produce electricity. And the downside of it is that, once again, it's a moderate yield. Two, it's the water that comes, the byproduct has to be treated, and it can be pretty challenging in terms of its acid and its hydrogen sulfide and sulfuric acid content. However, one of the advantages, like natural gas, which it is essentially, it's just produced in a different process, is that it can be liquefied into an automotive fuel. Now, I'm talking about automotive fuel because that's where we all feel it. That's where the big demand is. It uses most of the petroleum-based products, and it's the one that we constantly are being reminded that we're vulnerable to, at the risk of violating a grammar rule.